So, hello dear friends, once again welcome. Now let us do the question of the address by the method of section. Okay. So, what is the problem statement? Let us read. Using the method of sections, determine the axial forces in the bars for which 1, 2, and 3 of the tower loaded as shown in figure. Okay. So, this is the figure, and what do we have to do? So this is the member 1, or you can say bar 1. This one the member 1, member 2, member 3, और कह सकते हैं आप ये बार 1 है, मतलब कहाँ से कहाँ तक, from here to here, and from here to here it is the bar 2, and it is this one bar 3. ओके, और आप कर सकते हैं मेंबर्स. ओके, तो ट्रस किससे बना होता है? ट्रस आपके ये डिफरेंट मेंबर्स से बना होता है. ओके, सो नाउ लेट अस सॉल्व इट. सॉल्यूशन, एंड ट्रस इज मेड ऑफ स्लेंडर मेंबर्स. ओके, एंड शेप वाइज कैसा होता है? ऑफ जनरली triangular shape. Like this one. So this one. ठीक है. So you can say, or you can say this one. तो आप देख सकते हैं how many triangles are there? 1, 2, 3, 4. Okay, and how many members? So this one, and the middle one, this one. Okay, so in this way it is made of slender members of generally triangular shape. Okay, now what about the method of sections? Okay, so there are two methods. There are two methods. Okay, one is what? The method of joints. And second is method of sections. Okay, it is also known as the moment methods. Okay, so method of joints. So can I identify this joint? Like this is the joint, 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 this is the joint. Here it is the joint, it is the joint. तो method of joints में क्या करना पड़ते हैं कि suppose we want to know the forces in all the members, like this member, this member, this member, this member, and so on. Okay, so we use method of joints. Okay, and when we use method of sections, so suppose you have the whole structure, big structure, and suppose you want to know about the forces of the least members. Like in this case, only the forces of member 1, member 2, and member 3 we have to find out. ठीक है, तो हम सारे फोर्सेस को निकालें, फिर जो पूछा गया है वही निकालेंगे. ओके, एंड दिस मेथड ऑफ सेक्शंस इज आल्सो नोन एज मोमेंट मेथड्स. ओके, सो इसमें क्या होते हैं, आप सेक्शन कट करने होते हैं. कट करने के बाद आपका मीन्स कुछ जो फोर्सेस होते हैं वो जहाँ से फोर्सेस होते हैं उसको हम मोमेंट से फाइंड आउट करते हैं. ठीक है, एंड like equilibrium conditions, you know, the first one, summation of fx is equal to 0, summation of fy is equal to 0, and the summation of moment about any point is 0. ठीक है, so इसमें moment methods use करने होते हैं, moment supply करने होते हैं, then only we can get the unknown forces. Okay, now so अब हम क्या करेंगे, let us solve it, and this is the imaginary line section MN. आप देख सकते हैं MN. ठीक है, so now we cut from here. आप 2 पार्ट्स में कट कर दिए. so कट ऐसे करना है जिस मेंबर का आपको फोर्स फाइंड आउट करने हैं, वो मेंबर्स कट होने चाहिए, ठीक है। और मेंबर्स कितने होने चाहिए? मेंबर्स 3 से ज़्यादा नहीं होने चाहिए, ओके। अगर 3 से ज़्यादा होगा तो क्या होगा? वी डोंट हैव दैट मच ऑफ द इक्विलिब्रियम कंडीशंस, इक्वेशंस ऑफ equilibriums, okay. So that's why that is the limitation of this, okay. Okay, so now अब देखिए, अब हम यहाँ से कट कर दिए, okay. कट करने के बाद now you have option, you want to take this part or this part after cutting this, okay. So suppose you want to take this part, okay. So for the calculation you should know about the support reaction here and here, okay. So in this case we need to find out support reactions. If you take the lower section, okay, what about if you take the upper section? So there is a 1p, the given p, p is given force, okay, and nothing like to know about the supports, okay. So let us take the above part, okay. So अब हम क्या करते हैं, take this part and this one, it is it is A, it is B, it is C, it is D, and there is a diagonal in between which starts from C and ends at B, okay, and there is angle of alpha degree, okay. And what about from here A to B? It is A distance, and in between A to C it is H, okay. And what is the next? The next is, this is the part and this is the part, and this is the members which are cut now, okay. So this member is known as F1, it is F2, it is F3, suppose, okay. And suppose this point is where the F2 meets, this is the point E, okay. Now what is the next? And here it is, the P is given, okay. So how many unknowns we have? So unknowns we have F1, F2 and F3, okay. And the known forces we have the P, ठीक है. और बाकी no need to bother about the other parts, ठीक है. जो कट किए हैं उसी के बारे में सोचना है, okay. So now suppose we take moment about D, and suppose we take moment about D, okay, means we are applying the moment equilibrium, okay. So what we get, this is the D, okay. So आप देख सकते हैं F2 and F3 both are passing through the D. F2 and F3 are passing through the point D, okay. So that's why ये हमारे मोमेंट कैलकुलेशन में ये नहीं आएगा, ठीक है, बिकॉज कंकरेंट फोर्सेस है. एंड व्हाट एवर द नॉन कंकरेंट फोर्सेस, ठीक है, कि आप देख सकते हैं P एंड F1, ठीक है. तो हम क्या करेंगे, एंड डायरेक्शन वी हैव टू टेक. सो डायरेक्शन वी आर टेकिंग this suppose F1 means clockwise, suppose we take negative, okay. So if you talk about P, so P का डायरेक्शन कैसे है, if we are taking moment about D, so P will rotate the structure, the truss clockwise. So clockwise we are taking minus P, okay. What about the perpendicular distance? So perpendicular distance, that is the H from here, okay. इसका perpendicular P से आपका D का what is the difference, what is the distance, so it is multiplied by H, okay. What about F1? So F1 is trying to rotate the structure anti-clockwise. That's why we take positive here and F1. Okay, and what about the perpendicular distance? So perpendicular distance is here A. So it is multiplied by A is equal to 0. So from this, what we get? We get F1 A is equal to PH, and F1 is equal to PH divided by A. Okay, so one force we found out. Okay, what about the other? देखिए मोमेंट अबाउट डी लेने पे क्या मिला हमें F1. सो मोमेंट अबाउट सी लेने पे क्या मिलेगा F3 मिलेगा. ओके, सो नेक्स्ट इज why not to take moment about C, and its summation is 0 because it has to satisfy the equilibrium condition. Okay, okay, so you can see here now. So moment about C, then F1 will be 0, and F3 will try to rotate clockwise. So F3 with minus sign, and the perpendicular distance is what? So it is A. So it is multiplied by A. And what about the P here? Yeah, so here, through the practice, you have to know the moment we have to take about which point, so that less calculations are involved. Okay, suppose we take a moment about C and a moment about E. Okay, and what about C and the distance between C and E? It is H here. Okay, so you can see here, if you take a moment about C, so how many calculations are involved? This is the first step, and the second step will be what? P multiplied by then 2H. Sorry, 1H, moment about this one. And what about the F2, the vertical component? So F2 and a vertical component means sine alpha. Okay, means there are 3 terms. And what about suppose? So that's why whether we have to take it or not. So we have to just compare. Suppose moment about we take E. Okay, so what will be moment about E, then it is equal to minus F3 multiplied by A, and then the minus P multiplied by 2H is equal to 0. Okay, so देख सकते हैं here only 2 terms, here 3 terms. Okay, why? So which one is better? Moment about E. If you take moment about E, so क्या हो जाएगा? F2 is passing through this point E. So F2 can be neglected. There will be no perpendicular distance because it is concurrent force. And F1 will also not be considered in the calculation. Only F3 and P. Only 2 terms are there. Okay. So if we compare this one and this one. Okay. So this is little more here more calculations are involved. Okay, so why not to opt this one? Okay, so from here what we get? So we get F3A and is equal to what? Then minus P2H and F3 is equal to minus 2PH by A. So this we got. Okay, what about next? Okay, so what is next then? So as we have removed the upper part, this one. Okay, okay, and what is next? So next is to get F2. So better come here from this figure. Now we have to get the next stage is we have to find out the remaining force, that is F2, and it is inclined by alpha. Okay, so now what we can do, we can balance the horizontal forces. Okay, means summation of Fx is equal to 0, then P minus F2 cos alpha is equal to 0. Okay, then from here F2 is equal to P cos alpha. Okay, and what about cos alpha? So cos alpha is the A by, what is A? This is the A. Okay, this one you can say this one. Okay, this one and the diagonal. Okay, so base divided by diagonal, and it is h square plus a square. So in this way we found out all the forces F1, F2 and F3. So in this way we have solved. Thank you.